Hello and welcome to a new session of Hitchhiker's Guide to the Glamorous World. And I have here John Grant with me. Hello, John.
Hi, Tudor.
So why don't you tell us a little bit about yourself? And more interestingly is also what do you think Glamorous Toolkit is?
Sure. So I'm a software engineer by training. In 2004, I founded a business that tracks technology skills and demand-side labor market trends in the UK. So my focus now is more data science, AI, and the future of work. My work, the dynamic nature of digital and IT has led me to the belief that we need to normalize lifelong learning. AI and automation means that there's going to be disruption within the economy and the workplace. And I don't think we're in a position yet to adapt to that in the West. With regard to the Glamorous Toolkit and moldable development, if I shorten it to GT for this conversation, I became aware of it, I think, more than a year ago. It was a blip on my radar. I found the website, I think, but I didn't do more. I didn't dig deeper at the time. The other day, though, I was having a conversation with Simon Wardley. Now, Simon Wardley is the chap who devised the Wardley mapping framework, topographical business intelligence, and he was talking to me about it. Now, if Simon Wardley is talking about the Glamorous Toolkit, I need to take another look and a deep dive. So that's I hope that answers your question. Now today, so to do this, first thing I did is hit the website. Yes, then I found the Discord channel, which I joined. Then I discovered the YouTube channel. So I'm slowly working through what's the output there at the moment. But I've got 3 burning questions for today. If we only get through one, I'd be delighted by that. But
Sounds great. Sounds great. Yeah. And by the way, like Simon is an amazing person. So he can be overly kind. So let's see if we live up to the expectation today.
Okay. So my first question, this question relates to the mindset of today's software engineer or developer. Now, through experience and practice, programmers gain a sense, or they learn idioms, and they also patterns, and they learn anti-patterns. They learn to recognize them, and they learn to work with them to their advantage to make them productive and create functional, resilient code. Now, in a way, that kind of, when I was thinking about this earlier, it kind of relates to Wardley mapping, climatic patterns and doctrine. But the difference is those are codified. Simon Wardley has published those. He's put them into the public domain as Creative Commons that anybody can use. When it comes to programmers, often patterns that they learn to recognize are tacit. So often a programmer can come across as being a kind of Zen master. They're brilliant at what they can do. They can solve problems. They can write really fast, efficient, safe code. But from an outsider's point of view, it can often come across as a kind of career that's of mastering a craft or an art form, and that may alienate people. However, on the plus side, I've got to now defend my position because I am a software developer. The intent of developers can often be revealed in unit tests or test scripts. So if I'm looking for a new software library or a software module, In 2021, we can now go to GitHub, and often in any language that we work in, JavaScript, TypeScript, Python, you name it, there will be a module that you can start to make use of. And what I do, I can't speak for every developer, obviously, but what I do is I go straight to the test scripts, because they can reveal so much information about the intent and the constraints of what each function and module is supposed to do, more than probably what a developer could tell me, the bandwidth of the information that I can glean from test scripts. And if I don't understand what's happening by reading the code, I can then bring that to life by running it in a IDE and stepping through the code in a debugger. So it will reveal the state, and I can often go deeper into the framework if I'm using Go, all the libraries now, or even C#. The code is in the public domain. Now, I need to simplify this question. So if I talk about regular expressions, so regular expressions are extremely powerful. They've been around for decades. Every language now can handle regular expressions, and they're used, but there's many use cases for it. And there's also tools that are available in the public domain that take regular expressions to a higher level of abstraction. So you can type in a regular expression and it will plot a visualization of it to help you understand, to help you reason about what the regular expression is trying to do or it's trying to achieve. And you can also convert regular expressions into sentences. So it kind of, this step by step, this is what's going to happen next. But at the same time, even with those higher level tools, a lot of test scripts in order to stress test a particular regular expression, whether it was going into a load balancer in cloud to direct traffic, or whether it was to validate some kind of string input on a REST service point. So there's like all the development that's happened over time, and being able to go much further up in levels of abstraction and get a higher level view of what regular expressions do. I still have to resort back to working with 3GLs and test scripts. So the question is, given the preconceptions that I have and the acquired behavior, what would I need to unlearn or rethink to gain the most from moldable development and the GT toolkit?
Okay, this is very exciting. Well, thank you very much for that question. So let's see, how do we start it from? So one of the things you just described here is how multidimensional software is. Right? There's no single, it's not code, right? You just talked about tests, but then we say, oh, actually, tests can also be kind of like a piece of documentation too. So that because they can maybe describe the intent. But then we also talked about these other, technical sides, like the load balancer thing, and so which are maybe much harder to express in tests, right? Because that's not necessarily how you think of it. Like, what about performance? What about security? Those things are much harder to think of in terms of tests. But then you were also touching on regular expression. So, a lot of the things that people do today is they look at code, for example, they see text. And this is amazing to me, right? Because what regular expression is a tool that manipulates text. But of course, it implies that text has very loose structure. But code is dramatically, it's highly structured behind it. So just because its text is what we enter, that is not what what we've created is. So there are a couple of points I think here. So first of all, like one of the things that came out of that. So if you think about test revealing intent and test being useful for figuring out what somebody else said, It kind of this immediately leads us into this idea that code is actually knowledge, or codified knowledge, or executable knowledge. So we kind of, like if you look at, the space of, what people understand by knowledge management, and then what people understand by code, they would be perceiving those things as being completely different, which is, of course, not what the original idea of personal computing was. The original idea of personal computing was that the computer would be augmenting our abilities, not that it would compartmentalize our abilities into little tiny slots, for which we can, it's very hard to dive from one to another. So this would be maybe one of the things. But what should we unlearn? The first thing we should unlearn is that even though text dominates the presentation today, nothing we interact with is text. That's the very first thing we should unlearn. And a lot of things come from there. So we're saying that, like if you think about, you're correct in saying that a lot of the patterns that developers, employ many of them are implicit. But there was this very exciting movement in the 90s, started with the design patterns movement. And the exciting thing about that one was not the patterns, but this idea that also, of course, came from Christopher Alexander, that the most important part of the pattern is the name, because the name makes it explicit, and once you have it explicit, you can start to optimize around it. Things that we never have conversations about, never get optimized, right? And if you look, for example, at what Simon Wardley is doing with the Wardley Maps, it's also a similar thing. It's a reification of something that is otherwise implicit, and by reifying it, making it explicit, then you have a chance of actually finding a better understanding. And that's the interesting thing. So the largest chunk of time today being spent in development is actually not on constructing things. So all of that work around design patterns, right? You can think of it as like design, right? It's about constructing thing. If we look at, there are a lot of patterns there are a lot of practices today that help people build software faster. There are a lot of reusable things. The reusable item is also a way of making it explicit, so that some better thing can come out of that. So, like you say, frameworks and ways to deploy and so on. But a lot of this effort of making things explicit are specifically geared towards constructing things, to the point in which today the body of software grows non-linearly, but at the same time we are unable to recycle old systems. So from a macro pattern, right, we are swimming in legacy systems that nobody can move, or nobody can seem to be able to move. So from that perspective, for example, we don't behave any differently from the plastic industry. We're polluting the world that we're creating, and this would not be that bad if we would not be reshaping the whole world on top of software. So we kind of have to get this one right. Now, if you look, before you can to recycle a system means to take it apart and refurbish it for new purposes. Now, but before you can take it apart, you first have to understand the parts. Now let's look at how do people understand those parts, because that's basically where the bottleneck is, and that has to be rethought from the ground up. So today, developers spend most of their time figuring the system out. And most of that time is actually spent on reading. Now, the problem with reading is, reading is the most manual possible way to extract information out of data. And it doesn't scale. It's capped at a constant speed. You can read a little faster, but you will just increase it with some, fraction, but it will still be capped at a constant speed eventually. So that function cannot match the superlinear growth of software today. And we've since long overshot our abilities to understand that. We kind of didn't see it because we also exponentially increased the amount of people that are, trying to work around that problem. But you see the effects in things like, black boxes piled up on top of black boxes, And then you can measure the desperation by just simply looking at the questions people ask on Stack Overflow, right? Because on Stack Overflow, people go to ask questions about their own systems, right? And that's not what engineering is. You shouldn't go, you should be empowered to be able to go and reason about your own system. So the problem is actually reading, but there's a solution for it. And that's what basically moldable development is. The reason developers read code, for example, the reason why you were saying, I want to understand something, is because you want to understand something like, you maybe read tests as a strategy, but the goal here is always, there's a very specific intent. I want to understand it in order to do something. It's very rarely I want to understand it as I would, read a philosophy book. Sometimes you want to understand it because you're just learning a new something, and you learn a new language. But that's like there's like a narrow use case. Like the vast majority of time when people read code is because they want to understand enough to make a decision. Given that this is what occupies this is what occupies the largest energy that we spend in software development, we look at software development as being not a construction business, but primarily a decision-making business. And we are optimizing for that. That's what we are adding extra. And what we are also saying is that the reading needs are actually different from the writing needs. And just to say how far, what happens when we don't talk about things? Where do people read? What's the name of that tool?
Editor.
Edit.
Code editor.
It's about that tool was meant for something completely different. We used to have the problem that typing things in was hard. And we constructed a tool for that. And that tool is called the editor. And it's highly optimized for that specific part. And we got very good at it. But we now have the other part, which is about reading. And that reading is not served very well by the editor. So the way we're doing it is we're doing it the other way around. We're saying, well, everything about the system is data. Data has structure, but it doesn't have a shape. And we always need to reason. We always need a custom shape. We always need a custom shape to reason about anything. So if I give you a table in Excel, right, or if I give you a chart about the same table, if the question you have is answerable in the chart, you will find your answer with an order of magnitude, faster and better than if you would be looking at the table. So from this perspective, it means that it's not enough to just have data. The way you look at the data is essential too. And we have disregarded that part for the longest time. So what moldable development is simply saying the environment through which you're experiencing code is essential. And what's more is because software is highly contextual, it can't be rigid. So you have to be able to mold your environment to match your specific questions. And this is also an interesting thing, because for the longest time, there's all sorts of analysis, there are all sorts of visualizations out there, but they still don't seem to make a difference when it comes to, like when you look at what developers do, they're still going to read. Why do they do that, right? And maybe you want to say something?
Well, where you're going now is kind of leading into my second question, and I like.
Let's ask the second question.
I like the analogy that you made about the plastic industry and recycling, because the second question is really about software maintenance.
Mm-hmm.
And maintenance interests me across all aspects, but obviously, given my background, I think software maintenance is going to become a bigger problem than most people realize. And when you start to think in terms of technical debt, technical debt can be good, but there's also a form which is bad technical debt, as we have bad debt, the analogy in finance. Now, I'm just going to push things slightly just to broaden my understanding of where you're coming from with moldable development, especially. I do get the sense, listening to you, that kind of third generation languages in the paradigm that you're talking about is being relegated to a kind of intermediate representation. And again, moving forward with the things I've observed, and I'm applying a bit of Wardley Maps to this as well. So if we think about things evolving and where we're going to go next, in order to be able to handle these huge mountains of code that will need to be maintained for decades. So what we already have, COBOL is a legacy, and it's still around, and it's still driving critical systems in banking and in other areas. But we're going to see mountains of Java, mountains of C#, mountains of Python, JavaScript, which is, I can't, well, I won't go down that rabbit hole for now, but I think most people realize what I'm going to say. But also humans are moving up the stack. So to try and find developers with the talent to maintain that code is going to be not only difficult, it's going to be very expensive. At the point where this becomes such an issue that I'm talking about, humans will be wanting to learn quantum compute, or they'll be wanting to work in conversational programming, you know, the bleeding edge where you get some reward for the work that you put in. So the question is, linked to maintenance, could moldable development in the GT toolkit actually evolve into something that allows machines to reason about the system rather than humans? So this idea that we will have machines soon that can spot vulnerabilities, that can do code assessments, that can do language translation, in order to make whatever systems that are critical more resilient and easier to maintain.
Is this going to be doable to completely automate the evolution of a system to the point at which we will be able to create a general AI, which is still very much an open question? Then yes, we will be. If not, then no, because the problem is the thing here is that this intent is important. It's not the mechanics that are important. The intent is important. So, and context is the one thing that is the crucial thing. So what we see in software is the most contextual thing we've ever created as human species at such a small scale. Like you can put, just 10 people in a room, leave them there for 2 years, and then they'll be constructing the city, something that resembles a city in terms of how complicated it is. And the way that the system evolves is a complex scenario, which means that it is not predictable. We can only predict classes of problems, but we can't predict specific problems. And always value comes from specifics. So this is why I do think that we will be able to do a lot of automation, but it will be in tandem with the human being. And now you were talking about the maintenance problem in the future. I think the maintenance problem is in the past. Actually, it started a long time ago, and it's just increasing every single day. The problem is that, again, like, we are not talking about how do we deal with that. And that's the single most important mission we have. We want to get people to start talking about how they should not read code, because there's and start looking at software engineering as being primarily a decision-making activity, so that we have a chance of actually dealing with that. Because our kids will only know a world of software, and having that world of software be just a giant black box that nobody has a chance of going in is not a good future, right? We've already messed up one world. We shouldn't mess up the second one. For them. So, but as I said, I think there is a way to get out of it. So you were mentioning Wardley Maps. So let me share the screen here. And I'm trying to find the screen to share. So what you have here is a blog post. And I just opened that blog post in Glamorous Toolkit. So Glamorous Toolkit, this is what you see. And here on the right-hand side, you have a a feed from blog.fing.com. And if you click on one of these ones, you'll get the blog post. Um, so and this is actually one of the things that we're doing is that how do you deal with the legacy system? And specifically, we're talking about how do you deal with the legacy crisis? Um, because when we talk in abstract, the way we're talking now, it's entertaining, but people that have budgets, they don't seem to be moved very much by this. But on the other hand, when people have crises and they recognize that they have a crisis, maybe maybe the system is in the news for the wrong reason, for example. Maybe a large migration failed after a while, or something of that nature, or maybe that company has to change the core system in order to have a chance of competing in a economy that radically changed over the last year. So those things are recognizable as business problems. So this is why we're focusing our messaging on how do you deal with a crisis like that. But this actually applies to all sorts of problems that one would have about their own system. So let's decompose this a little bit. So we start with this is an interesting point. You were mentioning, for example, technical debt. I think technical debt was an amazing metaphor 30 years ago. We have to outgrow it in the meantime, because you can't. Technical debt is a very interesting economic tool, but it will never lead to profit. It will never lead to a positive. Like, it's a negative metaphor, in that the best case scenario is that you don't have debt. Like, this is not something people wake up in the morning for. But what if you can, what if you wake up to say, well, how many times did I smile today, for example? That's a much more interesting metric to aim for, right? And then one of the things that we're asking people is we're asking all sorts of questions. So we're asking people, do you love working with legacy systems? Right? And this is like a strange thing. Like, what do you mean love? Like, the question is here is, do I hate it very much, or can I live with it? Right? That's usually the range of choices. But we're thinking that, legacy is supposed to be something beautiful. In fact, in most other domains, legacy is associated with a positive thing, except in software, where it is associated with a negative thing. But legacy means value, and value should always be pleasant. So, the goal here is, how do we make dealing with legacy a beautiful experience and a rewarding experience? So, but coming back to the technical debt, one of the things that the technical debt did was to bridge this gap between technical people and business, right? In 2 worlds, it just bridged 2 worlds together. This is like an amazing, I think, achievement, right? We just have, and to this day, like 3 decades later, people are still, whenever these 2 worlds come together, they are still talking in terms of that metaphor. But this always places software as cost. Right, and then hence there are all the implications that come with that. But if you look at let's say a company that wants to compete, and let's say that they need to urgently digitalize, and they need to optimize the way they exploit the data that they have. But for this, it's not enough to change the data. You also have to change the software. And if you don't change the software, then your business is in danger. So the functionality of the software today is perfect. The problem is that the software tomorrow is likely is in question here. And the reason you might not be able to get to the software tomorrow, to the software you want tomorrow, is because of the structure of the software today. So all of a sudden, that technical detail simply needs to be elevated as a high-level business decision-making, because it is fundamental to the survival of the business. So I do think that we have to bridge that thing, but the conversation has to change. So let's say, the crisis affects both the technical thing and the business side. That's the interesting thing, as I said, when we talk about a crisis, is because this is a given already. Which in most other situations about maintenance, it's not necessarily so. So we start from there. Then afterwards, you get 2 things. So what you want is the crisis always starts with a specific problem. Always. There's always a specific thing, like the system is too slow, I don't know, for example, like all of a sudden we have all these unemployment requests, right, that we saw in New Jersey, for example, at the beginning of the pandemic. And that there's like a very large spike. We've never had anything like that before. And all of a sudden the system crashes exactly when people need it the most. That's a very specific problem, right? And specific problems always have to they have to be addressed. They have to be assessed, and by assessment I mean the process of understanding the situation about a system enough to be able to make a decision. So that's what I mean by assessment here. Now the problem is that how people are reasoning, like the input to assessment matters a great deal, because those are usually they also require custom views. Like we need to project onto the existing systems, we need to project, like draw a picture, right? So now, one of the other things that we're asking when people when we go into a company, we say, well, do you have a picture about your system? And they have say, yes, we have a picture, 2, 3, 4, 10. And they're very proud of those pictures. And then we ask another question. So, can you bet your salary that the picture is real? It's a simple question, right? And very few people can. In fact, we don't really meet them. So that's a problem, because now all of a sudden the input to what is supposed to be a very important decision can be just as well fake. You don't know. You believe you know, and that's why that's a belief. Every time you draw a picture manually about the existing system, you're actually depicting your own belief about what the system is. And beliefs should not be the input of any decisions. We've seen what happens when people do make decisions like that.
Can I ask a question there?
Yes, sure.
Again, what I'm trying to dig into is why this is going to matter.
Exactly.
I'm starting to form an opinion, but I want to hear it from you. Now, if I look at my experience that I have in machine learning, for example, visualization is used a lot there. So, for example, if you're training a model that's involves some kind of if you're minimizing your cost function, you need to see that. You need to be able to, you can't look at lines of code, you can't look at the editor, you have to visualize it, and often you have to use a form of dimensionality reduction in order for it to fit in the 2 dimensions that humans can work with, or we can put on a 2-dimensional screen. So again, I'm seeing that how moving up the stack or moving up the layers of abstraction is going to help humans navigate and gain situational awareness quicker of any system. But I'm still thinking that it also enables machines to do it as well. So it will be augmented by machines at the same time. I don't buy into artificial general intelligence, but I do think that I am confident, given my research that I've done, that it will improve lives. It will make us more productive. But I'm starting to think that, or question, is GT that layer that will enable that? Will it become the enabler? So in order for machines to improve business processes, optimization, find problems, and then maybe start to think about black swans and other things like that, or big tails, we will also need the machines to work alongside us at that level of abstraction.
Exactly. So yes, before we go to automation, we have to understand that currently, like today, right, we are doing the most manual possible thing to reason about our problem. And this is amazing, because it comes from the industry that automates everybody else's decision making. In fact, most systems in the world today, right? That's the crazy thing. Most systems in the world today, they help other humans make decisions without those humans ever seeing the raw data. Just think of that, right? This is crazy, right? Because we have this amazing magic skill of transforming raw data problems into information problems that can immediately inform decisions. And we can gain orders of magnitude improvements on how we make decisions. We know we've done this already. This is not like we don't have to invent anything. We simply have to take those skills we already have and apply it to our own problems.
If I could come on to my third question then, which I think you could weave into this as you go through the maps.
Let's see.
Hopefully, but it seems that the appropriate time to do this. Given the situation that we're in now, we're looking at a pandemic, we're looking at the possibility of a financial crisis, and somehow we've got to be able to work through this. So this question is more about resilience, and we use software to create software. I think we've established that it's kind of a weird, not weird situation, but often if you stand back and think about it, it has lots of...
It's a unique situation, right? It's a unique situation.
Yeah, it has lots of implications. Now, this is something that's I've been looking at many angles, and it's only by doing that, and I think this is what GT can do, is only by looking at it through different perspectives, I've started to appreciate why it's so important. So diversity enhances flexibility and the adaptive capacity of complex systems. So without the diversity, we don't have the means to adapt when we are stressed through a black swan. Use the word anti-fragile, if you like. Mm-hmm. Now, I'm starting to form my own opinions about GT, but I want to hear your thoughts on this. So do you think, here's the question, do you think GT is going to be able to address the gender balance and say neurodiversity in the field of software engineering? So if you go back to my first question, when I talked about the Zen master who works alone, who's some kind of can code anything. What we need is more people involved in this notion of coding, but it's more inclusive. So will GT lead to that change that needs to happen?
Okay, so let's take it step by step first. So one of the questions is who can make decisions? So let's just go through this one up to the end, and then we'll figure out where the problem is today. And there's a big unseen issue that I think needs or can immediately be solved. And the other thing to consider is Glamorous Toolkit is the beginning of the conversation. I'm talking about this thing for more than a decade now, but people don't listen to abstract things until you make them very, very concrete. So we actually constructed Glamorous Toolkit with a very simple, the main purpose of Glamorous Toolkit is to show what does this mean. We need to start the conversation. And like what happens after the conversation starts, lots of things, like the evolution is unpredictable. Nobody knows what's going to happen after that. I'm very convinced that there's a whole lot of things that can happen, good things and bad things, like with everything. But it has to happen as a conversation. So the issue here is, right, that we are having this, whenever we are making these decisions, how am I migrating this one to the cloud? I need to make it in smaller pieces so that I can, scale it better, for example. You need to actually look into the actual code. Like you can look at it at the business level, say, okay, this functionality needs to go in that, like whatever, your bounded context, for example, types of things. But then you have to actually perform the refactoring. And that's something that you have to go into the code. You have to untangle whatever is in there. And at the moment, people are doing it by means of manual views. They're not true. They're just fake. Nobody knows. It's just a belief. That's not what engineering should be. So the alternative there is to say, well, these manual views should be generated. Okay, so this is where automation is. So we're going from like something that is custom built to something that is a commodity. Generated views that we are using to make decisions, those have to become commodities. Now, this is where the tool becomes interesting, right? Because up to now, the tool was always relegated as a detail that developers should deal with. Who cares, right? Why do we care? But if you look at the how people are creating these manual views, and they are creating those manual views because through some manual inspections, most often some sort of reading. And this is because this is done like this this happens like this because the tools that are being used are very rigid. And what do I mean by rigid? Well, just think of this. Think of two systems that you might have seen. Think of two. If I give you two screenshots from two developers, if you stay like a meter away, you have no way of saying whether those systems come from the same system, those screenshots come from the same system or from completely two different domains. Because that's what, all of them, they show you exactly the same thing. Like the shape that hits my eye, it's exactly the same. It's just like a giant text editor with some, bells and whistles here and there. And so that's very, very rigid, but the problems that we have to deal with are very, very different. As I said, like the evolution of a system is a complex phenomenon, so you can't predict those. So you're going to need to adapt to the context. And the only way that people have at the moment is by basically reading. That's very malleable. The only problem with it is it doesn't scale. So the alternative to this, how do we handle this? These manual views are very interesting because they are contextual, right? They are specifically drawing only this one. Like we always hear people say, oh, I'm generating this diagram from here, but I don't see anything because they're just a mess of things. Of course, if you're going to generate all dependencies that you can possibly find at the level of abstraction the tool thinks is interesting, you're not going to see anything because there is no filtering that happened there. So the contextuality, we need those things to be generated, but we need those to be adapted to the context. This is where that's interesting, and it comes back to your, close to your question. How do we do that? So we do that through a little bit of snippet, like a little bit of coding that takes whatever data it is. It can be code, logs, configurations, data in the database, all sorts of things, and transform that data into something like a custom view. So for example, you were describing how, and this is actually interesting, how AI actually is using moldable development, but specifically only for that area, right? So we're going to see specific visualizations highly targeted for the algorithm that is being optimized through, right? So like you will have TensorFlow, visualization will be different than any other than other types of algorithms. Why? Because it's important. The detail there matters. You don't want to look at all objects and treat them, as being the same. You want to have specific things that this matters a great deal. So there needs to be craftsman, like somebody has to mold that view specifically for the problem. So this coding has to happen. Now, in order for this to be practical, and that's the key, in order for this to be practical, you need to have a set of tools that doesn't give you things out of the box, but allows you to build things very quickly out of the box. And that's what moldable development is. That's why we start here. And in fact, now you were talking about some major, very large patterns, like for example, diversity, right? This is something that we look, right? It's a macro level, right? We were talking about, the behavior of something I call the software environmentalism crisis, the macro behavior, right? We look at a legacy crisis. That's still not quite the macro, but it's still a large scale type of situation. In software, because software is used to build software, for example, this is one, but also because whatever you find at small scales of smaller scale levels of abstractions are the patterns that you find there are quite similar from the patterns that you find at largest levels of abstractions, because software has a fractal-like property. So because of that, if you want to affect large patterns, you don't start from the large patterns. You start from the smallest pattern. So when we did moldable development, we spent a good deal of the last decade of dealing with this to focusing on an exactly single problem, on a single question. How do I fundamentally change how I relate to a single object? We didn't start by saying, how do I change a large system or a large ecosystem? We started by saying, how do I deal with a single object? And because now we started there, and we think we have a very good idea of how that problem looks like. And so these kinds of views, these generated views, that are custom made for very specific contexts, is the key for us And to the point in which, for example, if you take, I've just seen some, in our case, if you take Glamorous Toolkit, and we say, well, we have here, if I take another presentation here, what do I mean by changing how I look at an object? So here are 6 objects, right? And most inspectors in the world, they see them through here's variable, here's value, right? That's what it, right? All of them are shown in exactly the same way, which is interesting because now I can reuse these views for all objects in the world, and it's exactly not interesting because they will never capture value, right? Because value is always contextual, right? Value matters in my context. So this view is, let's say, cheap because I get the return many times over, but it's not necessarily valuable. Now, if I take these 6 objects and you can't see from this, what's the difference between these objects? You don't know. But if I change these objects to this, right? I haven't done it. I haven't changed the objects. The only thing I've done, I changed how I look at the object. That's it. Then all of a sudden my brain completely changes differently. I can see, okay, I can recognize this is a fraction. I can recognize this is a folder. This is a picture. This is a Bezier curve, some sort of an algorithm, some data structure over here. So I can see now. And I can use those kinds of senses to start reasoning about that. And this is like a potential that we have not tapped into yet. So that's basically where we started from. Now we use the same environment, so we've basically validated this idea for pretty much a decade in various different forms. So for example, as a company, we work here, like in this space, to help people solve their crisis or legacy, and we're talking here about improvements that are measured into an order of magnitude. So can you reduce risk with an order of magnitude? Can you improve the effectiveness of your migration with an order of magnitude? That's basically what we are after. And all the work we're doing is free and open source. And our main intent is to get people to have the conversation, because it's only through that conversation that we will get to the implications of the implications of the implications. And we will finally get or we'll have a chance of actually getting to the very large patterns that we actually have to deal with, like the ones that you have mentioned. So today, right, decisions are really, really, like when we look into a company and we see people having a legacy system that they have to deal with, we see 2 concomitant fears happening at the same time. On the one hand, people fear that they have to change. On the other hand, they fear that they cannot change. And it's like when you are in between those 2 fears, it's excruciatingly painful. I mean, we think of developers as being or people in the IT. We are incredibly privileged, by the way, right? So we can do this work, whatever we're doing here. We can earn money while many other people have to be out and at risk during a pandemic. So that's an incredible privilege we have. And we should be blissful all the time. And yet people are miserable all the time. Yes. We have to change this thing. And this is why that's the conversation that we have to have. So I do hope that eventually we will solve the other larger problems, but I think that we have to do the due diligence and be patient and understand that we have for a decade, for half a century, we have only focused on half of the problem. And that's the part where we construct, and we have ignored the other part of the problem, which is what do we do with the system once we have it?
I appreciate that. That's made a lot more sense to me. Let me then fall back down to earth and be at the level that we are on the map. So if I'm looking at I'm going to do some reinterpretation and may try and pull in some analogies for people that might be listening to this that are thinking about skills and potential for what job roles might look like. So the specific coding on that map reminds me, I think you mentioned earlier that they're called inspectors. And then that is a dependency on views. So if I think about a SQL database, you can have views in a database which are essentially created often through a really complex SQL statement that only the schema designer understands. After that point, everybody consumes the view and works with that. So do you think there's going to be, or is there a potential for there to be inspector developers that work on the GT framework, that their primary role is to create these inspectors that look into and visualize for consumption for decision makers?
Right. So this is the process basically that we see happening. Somebody has a question, you want to apply an analysis, then you interpret the results. If you're confident, you act. If not, you repeat. That's the scientific method. There's nothing new there. The key only is that for your question, there's probably not going to be a tool, or not going to be an appropriate tool. So the key question to ask here is that, do you have the analysis? If you don't have the analysis, then you have to go and mold it. Now notice how there are two different perspectives. Like there's the red hat, and then there's the blue hat, or red hair and blue hair. So those are two different roles. They can be played by the same person. We actually often find in practice that it's more interesting to have two persons, even if both know how to do it. It's very similar to how, for example, pair programming works in terms of one, being at the level of the practicality and the other one at the strategic level. And you have a stakeholder that owns the decision and owns the question. And then you have the facilitator whose job is to support the stakeholder and provide the tool. Now, this facilitator is actually a cross-cutting role. It can be a generalist role that cross-cuts the bounded context of the stakeholder interests. And this is actually very much similar to what data scientists are today, right? So data scientists are most effective when they are embedded next to decision-making at the business level, right? We will be having facilitators. We want to have facilitators into the development process, deeply embedded together where the questions are. Most people will say, "Oh, when I need a visualization, then I'll do that." Well, we are seeing that developers we use dozens of views every single day, and most of those are actually thrown away. We build dozens of custom views every single day. We build custom views for every single problem we're doing. We start every single problem with a query, or most of our problems with a query. We're going to do visualizations while we work, as we do it. This is how different our flow is. That's why we never start with the editor. The editor comes at the very end of this flow because it's the least interesting thing to do. So it's a complete reversal. And now you were also mentioning something about tests as being an interesting source. I come back to that one just to be a little bit more on the ground as an interesting source of information, like of details of how do I get the intent. Now, we've built a different framework here, which is called examples. And an example is exactly like a test, except that. So let's take something here. So this is a price. This is a test for a price. It says here, I construct a price, and I assert now that the equal message, the equality, those two are actually equal. It's a very simple test, right? So this is from here up to here, you would say, well, this is a test, right? It's just a setup and then assert. That's what a test is. I construct an object, and then I assert it has the property I want. Now, if you think about tests, right, they are actually like with a TDD flow. If you follow the TDD flow, the test is only interesting when it's red. As soon as it's green, boom, it's no longer interesting, right? It's like you don't care about it anymore. Like it's just the job of the machine to run it. So we've done this little thing here, just a tiny change. So instead of this object, instead of throwing it away, because this is where the normal test-driven development frameworks stop. They create the object and then they assert and then say, "Boop, okay, now it's done. I don't care." We are returning this object or some object. We are letting this test, where we call it an example, we're letting it return an object. Now, when you take this one and you combine it with the view, because this is a view here, now I can build the documentation. I can build a narrative. I can build a narrative that I can give to all sorts of different kinds of people. So for example, here, I can see I have a concrete price of 100 euros, of which I discounted by money, 10 euros, so I get 90 euros. And then I discounted by percentage, 10% off, I get 81 euros, right? Notice how we reason about code without even actually reading the test. This is how far we can go, right? And then we can start documenting all sorts of interesting things. So at the end of the day, what we see Glamorous Toolkit be is a platform where we are authoring, consuming, and publishing stories or narratives about the inside of our software systems. Because at the end of the day, we want to make the inside of the software system explainable. And this kind of, if you look at these kinds of pictures here, and by the way, this is like a workflow, and I can interact with it here. I can say, oh, what is that? Oh, it's like this. And it's also decomposed into little pieces here. This is something that we can give to business people. In fact, that's what we mean by integration, right? The I in IDE was used to, or should stand for integrated, which means every single activity about the system should be handled in that environment. Which also means that, by the way, every time you leave the environment to do anything about your system, the I has failed, right? How many times does it fail in the current in current setups, right? A lot of the times, because the IDE today is synonymous to a good extent to editors, and that's wrong. We have to completely undo that. So that's just a hint of how we think the approach works and the implication that it has going upwards. But we have fundamentally changed the little tiniest thing. And out of that, when we start composing things, we're getting in a completely different world that kind of resembles things, but it has completely new properties.
Okay. So if I'm eager, and I think I've spotted, I'd like to jump in now and start looking at how do I build inspectors? Where would you say the first 3 things to go to start doing that?
When you start, so Glamorous Toolkit is a tool that you use to learn Glamorous Toolkit, of course, right? Because it's also a system, hence everything that we're doing for everything else has to be applicable on itself, including the way we explain what Glamorous Toolkit is. So when you start Glamorous Toolkit, you're for example, welcomed here with a couple of slideshows. So here is the slideshow about inspector views. So here it says, well, here's a list. And it says, well, it has this context there. And this is what the full name would be. And by the way, this is live. So if I, for example, change that one, then all of a sudden there's no line that goes there, right? And if I do this, there's a line that goes there. So a whole new level of explainability that can be added into the environment. And we can, everything about interacting with the inside of a software system can be incredibly, can be made incredibly beautiful. It can be exciting. There's no dull part in any software system. Once we change that, right, the energy that you generate out of that is just.
And would I be free to write inspectors in any language, or is that Smalltalk that I'm looking at there?
This is Smalltalk that you're looking at. The first language that we're supporting in Glamorous Toolkit is Smalltalk. We already have the beginning for things like JavaScript and Python. Glamorous Toolkit is a language with which you will build system-specific tools for all sorts of technologies, languages, APIs, any data sources you would want. It's a client-side view with which you compose the experience. It's the language of the shape. It's not the language of the system.
It's an extensible toolkit, but would that mean that at some point you could create inspectors in your own domain-specific language, even?
Yes.
Yes. Okay.
Yes, wow. That is the intent. Yes. So, for example, here is how we work. Imagine you go to this API things. So these are some publicly available APIs that give you some test data for, I don't know, to-dos, for example, here, right? Here, this is a description of how you would go about that. So we can use Glamorous Toolkit to, to giving this URL over here. We can actually produce this kind of group of to-dos here and save the information in there and then do things with it. So if I implemented that one, and by the way, this is an editor that can be unfolded like that. This is all live. So if I do this, right, I would get these kinds of to-dos, right? So all of a sudden I can see here, these are users. So this is a to-dos group, which is a specific class. It's an instance of a specific class. It has a specific view. If I click on that one, I'll go now to the user. This one did another call to the API, got me back another a user object. This one knows how to view itself. I can see here details about it. I can see the to-dos. I can see the posts. I can see albums. And if I go, for example, that album over here, it will do another query, gets me the album, and then here are the pictures. Now, these pictures are not downloaded lazily from the API. So, and yeah, they will appear here depending on how good the internet connection and the response is.
So these panels that are sliding to the left, these are views that are instantiated by inspectors.
These are inspectors. Every pane here is an inspector, and this is an object, and these are the views. So this is the views of an object. So here are the pictures.
Is it possible to switch to the source code at any time for that inspector?
Sure. So let's do this. I now just alt-clicked on it, and here's the source code.
Ah, right, yeah.
Right. Or let's do something. Okay, let's say here, for example, the details. I click on it, and so here are the details. Let's say if I change it, my details, and I save it, it changed. That's the idea. That the friction. Yeah. If you go back to the if we go back to this one, the friction here, the friction of creating this thing, this is the least interesting thing. Automation can happen here. So once we can, so here, for example, if you download Glamorous Toolkit, you will have more than 1,000 extensions, like 1,000 plugins from the beginning. You know, like the whole ecosystem of Visual Studio Code has 20,000 plugins. We have in the stock Glamorous Toolkit, we have 1,000, right? It's like the difference between monoliths and microservices, for example, little tiny things. And so you want this friction of constructing these views to be very, very small, which means that you will get a population, a very large population of views, which then is susceptible for actually saying, oh, you know, having machines suggesting, like having the completion should be, the inspector should give you, I see that you're kind of doing this. Are you not sure? Would you maybe be interested in this custom view? There should be, like, the inspector should give you completion in terms of, what about this view? Might be interesting. Right, and so there's a whole lot of potential for automation in that space.
So a rather mundane example, going back to your REST API, would I at some point in theory say be able to create an inspector that rather than using XPath, personally I don't like XPath, but could I write an inspector that actually sees that stream of data and converts it to a table, which I can then use SQL to query?
Yes,
and
absolutely.
I could do all that by just by creating a few inspectors to get to drill down to that. Yeah.
Why not? There's the possibility of combinations. We have not explored those. We're just at the very beginning of this. But you already will get, so, you know, people look at Glamorous Toolkit and they usually come with a specific problem and they see the solution to that problem. But then when you look at how many other problems people look at and see the specific to that one, right? Looking at it from the perspective of the features and the problems, the immediate problem it solves is the limiting factor. Glamorous Toolkit is a language, right? You wouldn't say, what kind of problems, what kind of systems can I implement with, you know, with a general purpose programming language? It used to be the case that some computers, like the whole hardware, was dedicated to just a few kinds of, or a few classes of problems. It was not a generally useful machine, right? And then we invented general kind of languages that will deal with all sorts of problems. And there the question is always how expensive is it to build it? But it's not whether or not it can build it. But today, developers split their activities across tool boundaries. So like, oh, I need to do dynamic analysis. I go to that tool. I need to check out the log. I go to some other tool, although those are completely the same kind of problems.
One thing that's starting to emerge in my understanding of this is we're moving to a cloud-centric world with desperate computational resources and distributed execution environments. Now, a lot of things in modern, say, JetBrains or Visual Studio, when you try and visualize parallel processes or concurrent processes, it's very difficult. You have to accept that the machine will really do the work for you as long as you obey the idioms that the language allows. But when you were looking at custom built solutions that isn't a programming language, then I can start to see this being, being able to create these inspectors on some cloud service somewhere, and they're saved safe in a data store. So my final thought, I think, for today is, will Microsoft or Amazon or Google acquire you this year or next?
We leave it up to them. But really, like the one thing we can do, right now, or we want to do right now, is to start the conversation. There is so much to talk about. This is the single largest expense. I mean, it's mind-boggling how expensive this thing is. I mean, just if you think about, there are estimated 40 million developers on GitHub. So let's say 40 million, let's say each of them costs $10,000 per year, which is a ridiculously low estimate, probably an order of magnitude too low. But let's even keep it like this. So it means like $400 billion every single year. Now, 50%, which is what people say developers spend on reading, means $200 billion per year budget being spent every single year. Nobody talks about it.
Yeah.
And so moldable development is a systematic discipline that is going to solve we already know, because we already have the case studies. And I can talk for about a week, I think. That's what usually a course is. And we don't repeat ourselves. We keep on saying this and this and this and this and this and this and this, because there are so many implications. This is why when people look at Glamorous Toolkit and they look at it, so what features does it have? It's going to appear very daunting, because you have like, like this and this and this and everything. But if you start looking at Glamorous Toolkit as a language, which is made out of visual and interactive operators, then it becomes it's very, very different in how you're learning it. So
you think the challenge is not to overwhelm people with too much, is to try and find a way of teaching the system that's more accessible to different perspectives and mindsets. But you mentioned courses. Are they on the website?
No, we're at the moment still doing them, privately when people.
Okay.
There are a few companies here and there that want to take a plunge and recognize that that there can be a huge, economic opportunity. We work with them, but all the lessons that we have are available, and we keep on talking about them all the time. And we would be very interested in getting other people to start teaching it. There are so many things to teach. We have never taught those things, not at scale. There are so many things to describe.
So that's a call to action now.
It is a call to action.
Yeah,
just to give you an idea. So let's say I want to teach the language. So this is actually implemented in Faro. Faro is a Smalltalk language. And one of the things, the first thing you might do when you're teaching a language is to teach syntax. So here's an example. This is a classic example that is being used in Smalltalk world to teach syntax. So you see here, this is a method that actually has all the syntactic parts. And this, the actual argument here is that Smalltalk syntax fits on a postcard. So, but here's a different way of taking that same thing and teaching syntax, right? So we can say, well, here are the arguments, right? This is a global. This is how super is and self. And these are literally everything in the access syntax tree, all the nodes, all the syntactic parts of it. And so you can see how they map here interactively, right? Which also means that, for example, if I take this one and I can maybe transform it into a string here, it means that if I go here and all of a sudden it finds it. This is a live place. Well, we can take it a step further. So if I now go and open here, a method. So I'll say print on maybe. So this is a method here. right? And by the way, like in Smalltalk, everything is an object, including code, right? So we can inspect the compile method, which I see, and that one will show me the source code. But there's another view over here which says, well, this is a syntax explanation. So if this one is an abstract, I require you to think abstractly, right? Because now I say, okay, now let's imagine that actually I care about this mumbo jumbo method, which is just has mumbo jumbo in it, just so that it can fit all the syntactic parts. But what if I care about this method, but I don't exactly know what these columns means here, right? Then all of a sudden I can do this. And this is now, I took the operator that was there for teaching general things. And now because I have the language that I can apply now on your syntax, your context, now it completely adds a new level of value. Now imagine this in the hands of people teaching, right? You can build custom views over custom views to teach and simulate many different aspects about the inside of software systems that were only rudimentarily explained until now, very often on the whiteboard or with some rigid visualizations that are still very generic. So, and yeah, I understand that it's a little bit hard to, you know, to figure out. That's how you can use the same thing to teach a newcomer as you use to reason about a large legacy system, but it actually is. Those two are actually not different spaces. All those rigid boundaries that exist today, they're just fake. They don't need to exist.
I can see connections between Wardley mapping. Wardley mapping is obviously a way of being able to put something down that can be challenged, so you don't challenge the storyteller directly. So similarly, exactly. This system exactly. Can generate views that can then generate more discussions that can channel challenges. But it's also starting to become more of a a teaching system at the same time. And that goes back to my question about maintenance and inclusivity. So I'm not overwhelmed, but I'm quite excited by the number of options I'd like to explore here. So I should get on with doing that.
Great.
All right then.
Thank you very much for the exciting conversation.
I hope at least
I hope at least I could get to to some degree to answer your very interesting questions.
Well, I was deliberately broad because I'm not familiar with the system, and it has done. So I'm grateful for the invite to this conversation. I hope it's useful to anybody that's listening, but I know where to go next, and I hope whoever's listening knows that as well.
Right, so people can join us indeed in the conversation. You can go to gtoolkit.com, download Glamorous Toolkit, play with it yourself, or join us on Discord. You will find us on gtoolkit.com. And yes, please do engage, and let's continue the conversation. Thank you very much.
Great, thanks. Bye-bye.
Bye.